Hey, if you look at this from top and then you accelerate time, it kind of looks like things are being stirred and mixed together, right? Now this gives me an idea. What if I actually take all of my planets and all of my dwarf planets and mix them into one? What will happen? What will I have? Welcome to What the Math. Hello and welcome. Today we're going to do a little experiment. We're going to try to take every single planet, every single asteroid, or I guess not every single one, but all the major ones, combine them into one and see what kind of a mass we're going to get. And basically the question I wanted to answer is, so how much stuff is there in our solar system flying around or orbiting around our sun? In other words, except for the actual sun, what else do we have and how much of it do we have? And specifically, what if we actually take all of this other matter that orbits the sun, combine it into one, and then use that to create customized planets like Earth? So how many of these planets can we make out of all of the material that flies around our sun? Can we actually make something awesome out of it? Let's find out. So we're going to do this from scratch. We're going to actually remove the sun and we're going to combine our planets. So let's go into the new simulation here. We're going to start adding planets. I'm going to actually slow down time and completely pause it. And we're going to start with obviously, well, let's start with terrestrial planets, I guess. We're going to put Mercury right here. So here's Mercury. We're then are going to put Venus right next to it. It's a little bit bigger. And I have to make sure that it's just standing still right next to Mercury, so they're actually going to be colliding with each other because we want to combine all of them together. We're going to put Earth next to them, and at the same time you get to see the size differences between various planets here. Mars is right here, and as you can see, Mars is a lot smaller than Venus and Earth. Now comes the big guy, Jupiter. Oh my god, so big. Okay, let's put Jupiter right here. We have Saturn, which is relatively big as well. And then we have Uranus, not as big, and finally Neptune. So that's the 8 planets that we have in our solar system, and we're going to combine all of them, mix them all up, and create randomized, customized planets. Now before that, let's actually add some more objects because we want to have as much mass in that one super object as possible. Now, before I do all this, just try to take a guess. How many, let's just say in terms of masses of Earth, how many Earths do you think this will create? If we combine all of this stuff together, how many masses of Earth will we have? Just to give you a hint, Mars is only about 0.1 or 10% of mass of Earth, whereas Uranus is 14.5 Earths. Earths. That is a very difficult word to pluralize. All right. Anyway, so yes, we have Earths. And we want to create as many of them as possible out of all of this mass. Now, we're not including Sun, obviously, because if I were to put Sun in here, it would be way too large and it would probably just make things a little bit more difficult for us. We're not going to bother with the Sun because we're going to assume, let's make an assumption, this is billions of years in the future when Sun has actually decided to go through nova and it has become a white dwarf. It has now become a white dwarf. So now we have to figure out how we're going to survive. We have all of the super technology of the future where we can actually mix planets and essentially kind of like 3D print them. We can 3D print customized planets out of material that we find in our solar system, which is the scenario of the future. So let's add some more stuff. So we have all of the planets. We're not going to put... we're now going to also add moons. So we're going to put our moon in here. We're also going to put Io, which is pretty massive. Let's put everything actually. Ganymede, Europa. You can see some of them are actually relatively large as well. And so here are some of the major moons here. You can kind of see the comparison of size. There's Io right there. There's Callisto. There's Titan right there. We're also going to add a few more minor objects. These are dwarf planets, of course. We're going to add Pluto right here next to Titan. We're also going to add all of these guys, including Ceres, Pallas, Sedna, Aries, and Makemake. So here's our dwarf planets, our major moons, and all of their other planets. We're gonna ignore the rest of the mass because honestly, if you were to add all of the asteroids from our solar system, they would not really add up to that much. They would actually not be as massive as even our moon. So, you know, it's not a big deal if we miss just those asteroids. But now what we're gonna do is we're gonna run the simulation, and what will happen is things will start colliding. Now I'm gonna show you the chart before we do all this. So this is what all of them look like together. Just a size comparison here from the biggest to the smallest, and the smallest is of course Chariklo. Here you are, little buddy. So here's our comparison of dwarf planets, moons, still moons, dwarf planets again, and moons, and here come the planets, and the last we have the gas giants. So alright, so we're gonna combine all of this mass and find out how many Earths in terms of mass can we actually create out of all of this stuff. Now, just to give you an idea, our sun contains approximately 330,000 Earths in mass. So it's basically 330,000 times bigger than Earth, which is quite a lot. But we only care about this material right here. So I'm going to actually make sure that I'm going to halt the velocities every once in a while, because there's going to be a lot of things flying apart really quickly. So, all right, here we go. Ready, steady, and go. And let's see what the first collision is going to be. This is actually in seconds per second. I may actually have to increase the time a little bit. And let the madness begin. Who's going to be first? What's going to be the first collision here? Things are not really moving that fast yet, but they are going to collide soon. Here comes Venus, I think, and Mercury. Venus and Mercury are going to meet Jupiter. And there they come. So Mercury collided with Jupiter. Venus did as well. And there's some fragments flying out, so we're going to hold velocities when this happens, because I want the fragments inside. Earth is joining Jupiter as well, and Jupiter and Saturn are coming together right here. Look at that. And bye-bye Earth. Thank you for all the water and all the fish. Fragments stop, and I'm going to stop the fragments again. Now, I actually haven't told you, but Jupiter is only about... Well, not only about, but it's actually about 300 times mass of Earth. So over 300 times mass of Earth. And so there is actually a very large chance that we're going to have something like 1,000 Earths mass. But it's very likely that I'm actually wrong, because I haven't really done this in practice yet. I've only done this in theory. Not sure how many yet, but we'll see. So here come the big gas giants colliding into Jupiter, because Jupiter is obviously the most massive one. And I'm slowing down all the fragments again, just so they can fall back into the gas giants here. Look at them collide. This is awesome. So many cool explosions here everywhere. From both sides, actually. Look at that. All right. Now, Jupiter is actually going to obviously heat up from all of this, but not enough to turn into a sun or anything like that. It won't have enough mass to become a sun, or even a brown dwarf, unfortunately. But it will have some cool explosions like this, and all these fragments flying out as well. Some of these fragments are very massive, actually. That's why I'm actually keeping them inside, because I want their mass. I want their mass inside of all of this stuff. And look at how long it takes for Saturn to join Jupiter. It's actually taking a really long time, because they're both so massive and so large that they need some extra time to basically collide with each other. And here comes the last gas giant collision. Uranus is coming closer and closer to Jupiter. It's going to be a pretty interesting sight. Oh, look at that. It just suddenly turned into some sort of a ice planet. Interesting. Alright, so here comes the last collision. Super explosion. Fragments flying out. We're going to stop them in 1 second. And it looks like there's really nothing except for this sort of a hybrid Saturn-Jupiter that's left. But hopefully they'll collide into one soon enough. And we can actually see Jupiter swallowing Saturn in real time as it loses its mass right here. It's losing mass in terms of Earths as it's being absorbed by the Jupiter supermassive giant here. And I think that's it. So, okay. Let's stop velocities once again, combine the rest of the fragments, and here we go. Here comes our supermassive Jupiter. So this is all of the planets and all of the dwarf planets and moons in one. Let's accelerate time a little bit so that it gets some time to kind of balance itself out, cool down, or actually first it's going to heat up. We're going to observe some of these explosions on the surface. It's going to really heat up. and then it's going to cool down. So what is the total mass? Well, it says here it's 1.47 masses of Jupiter. In other words, it's 147% of Jupiter mass. Well, how many is this in Earth's masses? Well, look at that. It's only 466 masses of Earth. In other words, if we were to combine everything, absolutely everything in our solar system, all together except for the sun, obviously, it would only give us about 466 masses of Earth. Now, does that mean we can actually make 466 Earths out of this? Not really, because if I were to go into materials, you would see that most of this, specifically 86.1% of this, is hydrogen, which is not really useful for us when we're making Earths. There's a lot of water, surprisingly, even more water than rock, so we can definitely make a huge water world if we wanted to. But in terms of actual rock and iron, which is what we need to have, you know, solid surfaces, there's only about 3.2% rock and only about 5.5% iron. So more iron for sure, but definitely not enough rock. Let's accelerate time and wait for this gas giant to cool down. And as you can see, it kind of actually acquired a bit of a wobble now, which can be seen better here because all of the collisions made it sort of wobble a little bit around its axis, which is pretty interesting. Alright, so let's try to do some math and let's try to calculate. So how many rocky planets can we actually make out of this huge massive bowl? So we're going to try to make a few rocky planets. We're going to put some water in them, and with the remainder of water we can possibly make a water world and maybe something else. And then we're going to also have a very large gas giant in the center, because this is how our new customized solar system is going to look like. So essentially what we're going to have, and we're imagining in the future here, we're going to have a white dwarf in the middle, which is essentially what our sun will become at some point in the future after about 6 to 7 billion years. And then we're going to have one gas giant that is going to be customly positioned in a specific location around that white dwarf. And out of the remainder, out of all of the rocky stuff in the center, we're going to make a few, possibly a few rocky planets, such as Earth, obviously, that will orbit around it. So, okay, let's do some math. So our total mass here is 466 Earths, and we have 5.47% of iron. How many Earths of iron is that? So we multiply this, and we multiply this together to get, and then of course we have to divide by 100 because it's percentages, and we get approximately 25.5 Earths of iron. The next one is rock, so actual rocky solid surface. So 3.21 multiplied by 466 and divided by 100. And this will give us the total number of rocky planets we can make. And this is approximately 15. So we can actually make about 15 different Earth-like planets. This here, 522, this is water. So multiply this by 466 and divide by 100. And we're going to get 24. So we can make 24 water worlds. And lastly, we need to figure out how big our gas giant is going to be, and this is going to be 86% of hydrogen. So 86% multiplied by 466 divided by 100, and this will give us approximately 403 masses of Earth in terms of the size of a gas giant. Alright, now that we've done the math, let's try to create a completely new solar system. And here's our sun as a white dwarf, and it's after the nova that it undergoes in about 6 to 7 billion years. And so it's not going to produce as much heat, it's not going to produce as much warmth. So obviously we need to place our our planets and our orbiting objects around those planets a little bit closer. So original distance for Earth was of course 1 astronomical unit, which is about here. But if I were to place Earth here, it would be completely frozen because this white dwarf is so tiny. It's not going to provide enough heat for us, unfortunately. So instead, we're going to choose a location somewhere around here, about 5 million kilometers away from the white dwarf, about 30 times closer to the sun as we are right now. And we're going to place our customized gas giant right here. Now, so here is our customly made gas giant. We're going to change it a little bit to make it more gassy. And also we're going to give it mass of 433 Earths. So this is going to be our center of the new solar system. It's going to be a gas giant that is going to protect us from things like meteorites and asteroids, because it's going to basically be so massive that it's just going to vacuum them up. It's 1.36 times the Jupiter, so it's already pretty massive. And it's also obviously going to have a very, very large magnetic field of about 8,000 Gauss. If you don't know what that means, it just means it's a very powerful magnet, and here is what it is going to look like. Its magnetic field is going to protect us from all of the possible solar radiation or any kind of dangerous X-rays and gamma rays from space, and basically will support the life on our planet that we're about to create. It's going to orbit this white dwarf, and I hope this provides enough heat for us, because I'm not sure if I put it far enough or close enough to the sun. Now, as I mentioned, we can actually create 15 rocky planets, and we were obviously going to mix them up with some of the iron and some of the water just to make them more terrestrial. And so let's do that. So we're going to place 15 terraformed planets around this object. And here comes our first terrestrial planet. This is the first object orbiting our beautiful gas giant. And this planet is called Eustace. This is a randomly generated name that I haven't really chosen, but it needs a little bit more water for it to be more terraformed. You can see there's like these canals here. They're about to become more watery. As soon as we add, here we go. Look at that, beautiful. So this is our first terraformed planet. Its temperature is approximately 10 degrees Celsius. It goes up and down a little bit. And well, obviously we're orbiting this massive gas giant, so there's possibly things like tidal heating and tidal effects from it. Of course, we can disable that by pressing this button right here that shows us. That's called tidal lock. So if I tidally lock this, it will now spin with our gas giant and be always tidally locked to it, so that we are not going to be experiencing any kind of earthquakes or any kind of tidal heating from the gas giant. Which means that we can maintain our beautiful temperature of 10 degrees Celsius. So this is our first planet. We can now make 14 more of these. And like I mentioned before, this gas giant is going to be protecting our new home planet, our new world, from all of the radiation, from all of the meteorites and large objects approaching our solar system. And it's going to be basically absorbing them into itself. Now, things are about to get more difficult as I add more of these planets, because they will actually start influencing each other. So I'm going to try to add another one without causing any collisions. And so I've placed all the 15 terrestrial planets around my beautiful Nox, and we can actually look at them by going into the chart, just so you can see what they actually look like. And actually look at the size of the white dwarf. It's even smaller than the gas giant. It's about the size of Earth, actually. So this is all 14, or actually sorry, all 15 of them, all different shapes. Some of them have more mass, some of them have less mass. And they're all slightly different, just because some people might like different climates. So we basically created climates for different kinds of people. And let's see if they actually do behave, and if they orbit around the gas giant relatively nicely without collapsing. I may have actually overestimated my godlike powers when I was placing these objects around each other. And they may start colliding, unfortunately, but hopefully they don't. Anyway, so this is what it would look like in the future if we actually created this custom sort of system of terrestrial planets. You didn't see that. Nothing happened. You saw nothing. 13 planets now, I think, maybe 14. Anyway, so yes, it would look something like this. It would be orbiting around this beautiful gas giant, and they would be all kind of customized for different types of climates, for different types of people. And like I said, we can actually add some more planets. 25 of them can be made completely out of iron, and then 24 can be completely covered in water, so they'll be more like water giants. Now, all of this would be possible in the future if one day we actually combine all of the materials from our solar system into one big chunk, and then sort of divided it into little parts that would then become different planets. Now, surprisingly, all of my planets are still actually orbiting, except for the one that actually collided with my gas giant. But these guys are fine, and the temperature is not too bad. It's about 30 degrees here, and it's about 11 degrees here. So they're actually relatively nice and comfortable. This one here is a bit too toasty. It's 168 degrees Celsius. This one is just right, and this one is 100 degrees. We can obviously adjust this by playing around with some of the settings. Like if I increase albedo, the temperature will actually drop. So I think I'm going to pause this video here. Hopefully you guys enjoyed this, and hopefully you learned a little bit more about all of the different masses in our solar system, other than obviously the mass of the sun. And in one of the future videos, we might explore this a little bit more, and maybe I'll even try to succeed in creating this customized solar system with 24 iron planets, 24 water planets, and 15 terrestrial planets. But you know what? This is actually a lot harder than it sounds, because placing so many objects into stable orbit around each other is actually a lot more challenging than it sounds. So I may have to play around with this and figure out how I'm going to do this in the future. Anyway, thank you so much for watching. Hopefully you enjoyed this. Game you later, guys, and bye-bye.